Hey everybody, how's it going? So, this was supposed to be my glorious moment where I showed that CUDA was executing faster than multi-threaded C++. However, I'm afraid that is not the case. We ran a set count size of 1000 and array count size of 100 million in both the CUDA version and the multi-threaded C++ version, and the multi-threaded C++ version was just a couple of. It wasn't a negligible amount faster. It was. I mean, they're just the same order of magnitude, but I mean, I just wanted the CUDA to absolutely blow C++ out of the water, and it didn't. So at this point, either I make CUDA faster, or I use C++, and I just feel dirty even saying that. I mean, multi-threaded C++, I haven't messed with that since like 2004, and I certainly don't want to go back. Now, what did occur to me is that down here in the CUDA code, I am setting all of this information separately. And maybe I don't need to do that. So the benchmark that we need to beat, here, let's write this down. Benchmark to beat is 1000 sets times, here, let's just copy it so we don't get confused on zeros. That many, what is it, array size in 5 point, let's just round it up. 5 point, no, because we're going to beat it. We don't want to round it up. 5.45 seconds. 5.45 seconds. So, yeah. So let's start off. Well, first off, let's tone this down a little bit and look at what we're doing here. So I will comment out the Python CPU values so that I can just show what we're doing and verify that we are getting our expected results. So we have these sets, 100 of them. These are constant, so I can change them easily. And then an array size, this is going to represent a stream of words from multiple stories. Now, I'm not going to do any set reduction. So if the word the appears twice, then it'll be counted twice. I mean, assuming it's inside of the set. And then it's split into blocks of 50 each. Now, the array size has to be a multiple of the block size. Actually, let's put that right here. Let's say 0 equals array size mod block size. And then it's clear. Array size must be divisible by block size. And then we raise it to the 4th power. And because the block size is always the same, I don't need to do any floating point division or anything like that. I can just count it as an integer. It needs to be a 64-bit integer, but an integer nonetheless. So the highest number you could possibly get is 250 squared. What is that? 250 times 250. Wait a minute. That's pretty low. Did I do that wrong? Oh, it's not 250. It's 2500 squared. Yeah. So, yeah, okay. I'm like, wait, that doesn't look like it's going to overflow. So let's see. There's probably a way to load these to front load the sets. And so I'm hoping that ChatGPT has some ideas. So let's move this in here. You know, we can probably remove the CPU portion. CUDA count single set. No. We're leaving it. We're leaving it exactly the way that it is. CUDA count. Actually, I do need to rename this. Come on. Okay, CUDA count working. And then we will have a CUDA count experiment. Probably I should use branching or something, but whatever. CUDA count experiment. So let's come in here, load up ChatGPT. I would like to speed up the calculation by passing all of the sets at the same time. Speed up the CUDA calculation by passing all of the sets at the same time. How do you propose I do this? Because we have to beat the C++, otherwise we're using the C++. It doesn't matter my personal feelings. I need to use the best tool for the job. And I'm not convinced that the GPU isn't actually the best for the job. I just think that I'm passing data to it inefficiently. Now, maybe what I'm supposed to do is I'm actually supposed to do the evolution inside of the GPU. A little bit nervous about that, so we'll see. All right, so it's thinking. Scoring kernel, all sets. What did I? Oh, one set. I like that. All set stream result block size, all set shape. So is it going to turn it into a two-dimensional array? Is that what it's doing? Scoring GPU results. In the revised code, scoring kernel function is modified to process multiple sets in parallel by using 2D grid of threads. Each block in the grid handles one set, and each thread in a block processes a portion of the stream. This approach should significantly improve performance, especially for large data sets. Remember, the optimal configurations may vary based on your specific GPU architecture and on the size of your data, so it's worthwhile to experiment with different settings. That is true. I'm going to assume that it's safe to leave these alone. All right. Because I need it in that format for these. Okay, processing time, CPU. Now we're going to come down here. Paste. Is it angry about anything? Nothing? Okay, let's see what this does. Now, for these small numbers, it might not speed up, but I need to see if it's going to return the same results. Okay, it should not take very long to execute. List object has no attribute size. I'm not actually opposed to switching this to using NumPy. That's fine. Hey, maybe using NumPy actually gives us some sort of a speed up that I'm not even taking into consideration. So let's see. NP random randint 0 to max value. Let's do max value plus 15. Size, array size, and then 0 to 2. I'm assuming that's exclusive. Well, we would know. All right. I want to see the data. All the sets 0 to, I don't know, 20. All the sets. Every set. This is a two-dimensional array. This is going to be too big, but I want to see what it's doing. Well, no, it would be like this. It would be 0 to 20, because I mean it's still just a. Okay, let's see what it does. index 25005 is out of bounds for axis 0 with size 25,000. That is true. Now let's come in here and if stream no. That's not how we do it. We will simply allow a 0 to end at the end of a set for an undefined value, and we'll just leave it always that way. I can work around that. That's not the issue. Okay, 1101, 110000, etc., etc. Let's see what it does. Now, for this set count and this array size, processing time, the truth value of an array with more than one element is an ambiguous. Expected values, what is going on? The scoring CPU. Expected values, GPU results. What are the GPU results? Show me what this is. Oh, it did. It's an array of arrays. Expected values, GPU results. We can evaluate this. Processing time, CPU is 13 seconds. Processing time GPU is 0.34 seconds. That's pretty significant. Now, will it compete with C++? That's a different question. But let's run this again and just see if we can visually verify that it's returning the same values. All right. These look the same to me. Do they look the same to you? All right. Yes. This is complaining. I should know how to use NumPy well enough to fix this, but I just don't. Okay. So I do want to make sure that it matches. I just want to do it the right way. Okay, let's see if this gives the same results. I think we can stop printing that. I just wanted to visualize to make sure that it was giving me what I expected. So yeah, the scoring CPU, we're going to comment this out. There is no more CPU. Now, the expected values, this is not going to be a thing. This is not going to be a thing. So just the GPU. Show me. GPU 0.31 seconds for this. But what were we trying to beat? 1,100 million array size. This is where, I mean, it's either going to work or it's not. So let's see. CUDA error invalid value. What are you angry about? GPU results. Scoring kernel. Blocks per grid size. CU launch kernel results. CUDA error invalid value. I tried changing the constants to got this error. Save me, I don't know what I'm doing. Maybe it's too big to fit in VRAM. No. The error CUDA error invalid value in CUDA programming often arises due to issues the kernel launch process and memory allocation that exceed the limits of your GPU. When you significantly increase set count and array size, it's likely that you're hitting... CUDA GPUs have limits on the dimensions of the grid and blocks that can be launched. The number of threads per block is limited. Memory allocation. Here's a revised approach. Max threads per block is 512. Okay. I'm gonna try using this suggestion first. So max threads per block. Scoring GPU. Shit, I don't know where it's. Adjust grid dimensions. Scoring kernel. So it's down to here. Blocks per grid. Well, let's see if that works. Too many blocks required per grid. Consider reducing the workload. What if we got rid of this? CUDA error invalid value. Maybe we can only run 100 at a time. CUDA error invalid value. 1, 2, 3, 1, 2, 3. But it doesn't make any sense. I did this before. I did 100 million before. That's where I got the, remember? CUDA count experiment. CUDA count working. This was working. I mean, it wasn't as fast as the C++, but it was working. I like the two-dimensional grid setup. Well, I'm not actually going to be running against 100 million, though. Does it matter if it's not working? Well, it matters for demonstrating if it can beat the C++. No, but you can rerun the C++. That is true. That is true. I can rerun the C++. Let's get rid of the benchmark to beat thing. We are starting over again in the experiment. CUDA count working. Got rid of it. The initialization is done. As soon as it says processing time CPU, it should spit out 0 because this is effectively nil. Okay, and then the rest of the everything should work, and then it should throw an assertion here. Okay, processing time GPU is 10.04 seconds. So, NP zeros. 10.04 seconds. That sounds good to me. Maybe that is good enough. But I wanted the original code here. This seemed to be working. I think that we need to verify that it's working, but okay. We come in here to experiment. Paste here. And paste here. And then we just have to change the assert statement. Assert, assert, assert. Where's the assert? I do not see the assert. Did I delete the assert by accident? Probably. Print expected values. 10. So for the smaller number, set count 100, array size 1 million. That should execute in Python and the GPU pretty fast. Results did not match. Well, the results didn't match. That's kind of a problem. I think we're going to have to call this one a failure. CUDA count working is fine. It executes half as fast as the C++. I think that that's okay. It runs many times faster than the Python version, and I want to write in Python, so it's just gonna have to deal with it. Okay, so let's see what's going on. Make sure that this passes the verification. One, two, three, 1, 2, 3. Oh, this is, oh, wow. Okay, this is going to take way too long. I'm sorry, I didn't mean to run that. I did not mean to run that with the CPU calculation turned on. So we'll run this, and 5.45 seconds. I think we're just going to accept that it's going to run slower and move forward with our lives. Little disappointed, but I'm not about to try to actually evolve inside of the GPU. That's not reasonable. That's not what I'm going to do. So I wanted it to be faster. Okay, so 1,100 million. Now, what I was actually planning on running was 300 and you know, I was gonna do 10 million, but maybe 1 million is fine. That's like 20 novels worth of text. That's quite a bit of text. Yeah, so 10 seconds. About half as slow. Let's see how long this one takes. And let's compare that against the raw Python. Now, I probably wouldn't use raw Python. I would probably spin up 31 processes, but we'll figure it out. This should go much faster. 301 million. Come on. Ready to move on. Okay, so 16.8244 divided by 0.72286. 23 times faster. That's interesting. That's interesting because that means that the CUDA is actually slower than running the Python itself. If we ran this code 100 times, it would increase by 100 times. But if we ran the scoring kernel 100 times, not necessarily. How would I modify this code to run 100 times? I'm trying to simulate the speed improvement of not switching between CPU and GPU. To run your CUDA kernel multiple times without transferring data back and forth between the CPU and GPU, you can simply loop over the kernel execution within the GPU function. Where is it? Scoring kernel. So it's just this part. Where is it? Scoring GPU. Scoring kernel. Okay. So for I in range, I don't know, 100. I want to see how this ramps. And then I'm pretty sure that the CPU time would simply scale up directly. So run. So we're going to execute this 100 times. Maybe we will be evolving inside of the CPU. It makes me nervous because I'm not used to modifying this code. It all just kind of confuses me. But if we can apply the evolution there, then you know what? Maybe there's a chance. Oh dear Lord! Look at that. Look at that. Holy crap. You know what this means? It means that the overwhelming amount of time that we're spending is spent transferring data to the GPU. So yeah, no, it did speed up. But look at that, thousands of times. It's 16, well, no, not quite. Here, let's figure it out. Closer, 1658 point, no, that part doesn't matter. 987,689 divided by 1.88393. It ran 880 times faster. Does CUDA have... Does CUDA... No. We're gonna have the proposed evolutions. Python will still generate them. Maybe we could pass in one block with up to 100. That doesn't make any sense. Well, we have sets, and we have unsets. So if we had a conditional pairing, okay. Does CUDA have a library for random numbers? If it doesn't, we could pass random numbers. Yes, CUDA provides a library for generating random numbers called CURAND. The CURAND library is divided for CUDA applications, various pseudo-random, quasi-random, and device API generators. Here are some key points. CURAND supports different type of random number generators. The most commonly used quasi-random number generators like Sobol, host and device. Random number generation can be seamlessly integrated into CUDA kernels, allowing you to generate and use random numbers in the same kernel. Okay. Using random numbers in parallel computations, especially with CUDA, requires careful consideration for the independence of random number sequences in different threads to avoid statistical correlations in the results. Could I simply generate a large number of crypto random numbers and pass it to CUDA? You can generate a large number of cryptographically secure random numbers on the CPU using a cryptographic library and then pass them to CUDA for processing. This approach is often used when cryptographic security of random numbers is a priority and the overhead of transferring these numbers to from the CPU to the GPU is acceptable in your application. Generate cryptographically secure random numbers. Use a cryptographic library in Python. Transfer to GPU using CUDA kernel. Remember that while secrets and os.urandom are suitable for cryptographic applications, they may not be as fast as non-cryptographic random number generators. Is there a library for creating crypto random numbers inside of the GPU using a 256-bit key? Yes, there are libraries and methods available for generating cryptographically secure random number generators on the GPU, especially using keys like a 256-bit key for encryption and seeding. However, these are typically more complex and specialized than standard random number generators. Well, no shit. It's more focused on statistical rather than cryptographic randomness. For cryptographic purposes, you might consider the following options. CURAND is designed for statistical randomness. It offers some features that can be used, such as I am running. Can I access NVIDIA CURAND from Python in my current application? You can access NVIDIA's CURAND library from Python, but this typically involves using a Python library that provides bindings. That's fine. The most common way to do this is through PyCUDA Python library that allows you to access CUDA functions. PyCUDA. Basically, I'd be rewriting from scratch. I don't necessarily want that. I mean, I'm passing numbers anyway. Why can't I pass the evolutions? I think I can. I think I can pass the evolutions. So we're going to have on, off, and it's going to undo the previous ones. We are going to have you know what? I think I'm getting ahead of myself. I think it's fast enough as it is, and I should stop worrying about the speed, and I should start worrying about the implementation. And if I find that I need to run it 10 times longer than I thought, then I can come back to optimization later. I think I'm going the wrong direction with this. So, CUDA count working. We don't want to mess with that. let's tune these down just in case somebody, me, stumbles across the code. I think a million is a good size. So we are going to move ahead with this in this format. Let's say CUDA count working, and we're going to have evolution. So new Python file, evolve curric. Hopefully I didn't already name something that. Dynamically generate curriculum. Well, this is something that's been on my mind, that's for sure. So yeah. Okay. So file name equals that. Or JSON with open. Oh, thank you. Coding UTF-8 as F, and then we'll say, oh man, I love autocomplete. That's great. Okay. So print data.keys. This is not a particularly large file, so position to number, number to position, and original position counter. All right, 4K in data.keys for, I don't know, item in K, data of K dot items key value in data.items. Print key value and break. So we are going to print this like this. So yeah. Now these are strings. These will need to be converted. One, two, three, four, and then it's going to be key, and then in parentheses type key, and then value, and obviously, come on, Luke. Obviously, type of value, not dot name. Actually, dot name might be just fine. I might like dot name. Wait, give it back. Whatever. Okay. Evolve correct. Why are you angry? All right. So, string int. The int is fine. What is it? Is it eval? Print eval 4 plus 5. Okay, yeah, that's fine. So print eval sweet. That's what we want. So we need to change this. We are going to have three of these. We're going to have position to number, number to position, and original position counter equals equals, and then in each case, obviously, it will be a dictionary. And it's going to be, so the first one is string to int. So it's going to be 4k comma v in data.items, but it's not data.items, it's data position to number items. So let's just start off with a template kind of like this. And then in the first one, we need and then in the second one, we need and that maps to a tuple. And then in the last one, it's going to be a tuple to an int. The tuple is right. All right. I don't think we need this anymore. I don't think we need this anymore. I think we have loaded our data, but let's take a look. Type of pos to num dot pop. No, pop requires a freaking. You need a key. You can't pop from a dictionary without a key. Will this work? I have 3 dictionaries. How do I print the type of the key and value? They are uniform, so looking at the first entry would be fine. You would first need to access an item. Yes, that's what I wanted to do with the pop. That was the purpose for the pop. Okay, run. Tuple to int to tuple, and tuple to int. So yeah, that's exactly what I want. So we can look at what the data is right here. So we want int to num. Let's find so that's the very first one. Pronoun. Adverb. Probably could have done this ourselves. Whatever. Okay, so evolve curriculum. So our standard curriculum is going to be the first 10 most common items, because let's face it, the 10 most common we need. The and a, to, was, she, he, it, they. As I was saying, we want the first 8 items, right? The first 8 items plus part of speech to number of something plus part of speech of number to something. And let's find what we want. It'll be here. We want dog and cat. Dog. Well, we're intelligent human beings, right? Print standard, and let's see what we have. It may be a marketing gimmick, but you know what? I think that's okay. People like talking about their pets, so can only concatenate list. You know, that felt wrong as I was typing it. I should have listened to my gut. So 0, 1, 2, 3, 4, 5, 6, 7, 82, 98. Those are not that uncommon to begin with. And that should be 10 items. Now we need to create the thing, we need to create the parts of speech that we're going to be using. So part of speech 2, add parts of speech to tiny stories, read all JSON files and make output. Yeah. So we're going to go through here. And we are going to get these parts of speech. Now, I don't know how long this is going to take. I should probably add timers in here. st equals time.time. Put library. En equals time, not end. En equals time.time. Sorry, that's my muscle memory. Print elapsed time en minus st seconds. Run. OS, where is it? 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 I keep wanting to go to, what did I do? I keep wanting to go to the end with my mouse, so I'll just stop fighting it and move it there. So elapsed time is 3.729 seconds. Generating that is pretty fast, so 3 point, yeah. Okay, we're only going to use things in POS 2. So this gets all of the file names, and now we need to shuffle it. So shuffled. Okay, so while all files are gonna, no, that would probably work, but whatever. Shuffled dot append all files dot pop rand secure. What the hell? Rand below. Secrets, not secure. Secrets. Secrets dot rand below length of all files. Exactly. Now, print length of all files, comma, length of shuffled. And they should switch places, and it should not take very long. So, here we go. Okay, I got to admit this is taking longer than I thought. What is the average length of the story? I can't imagine it being less than like 20. So we want 1,000,000 divided by 20. We would need 50,000 stories, right? Let's just do 100,000. So stop. while all files and length of shuffled is less than, I really think 50,000 is going to be enough. So run. All right, that took 11.287 seconds. So yeah, now we're going to say this is going to be our items. Let's call it a story stream, because I think that's what I called it in the other one. And we're going, yeah, for path and shuffled. There we go. Oh my God. I don't know what to do. For part of speech in data, print part of speech. I'm sorry. This is just, it's moving too fast. I need to see it work. Please. Yeah. If length of all files is greater than 100, 1, 2, 3, then break. Probably speed it up a little bit. I'll remove that at the end. Once. Lots of once upon a times. Lots and lots of once upon a times. Probably too many, but whatever. Not going to complain. Unless that's what I'm doing right now. Okay. First thing to notice here, this is coming in as a list. So we need part of speech list, and then we want part of speech equals tuple of part of speech list. And then we want part of speech number equals part of speech to number of part of speech, and then that append part of speech number, like that. And then files equals 0. Files plus equals 1. If length of story stream is greater than 3, 1, 2, 3. If it's greater than 1 million, then break. While length of story stream is greater than 1 million, we're going to say story stream dot pop. So that'll get it down. And then let's see, print files, so we can know how many that we looked at. Now I'm going to remove this so that everything has a fair shot before I do the final. Oh, right. We need to set it to something that isn't going to appear. So let's go here. Else POSN equals, I don't know, what do we want it to be? -1? I don't think it should be a positive integer. I think it should be -1. So if we want to change it later when we pass it to CUDA, that's fine. But -1 is pretty clear to me. That's not a real value. So here we go. And that also keeps us from getting stuck in a corner if at some later point in time we decide that we want to add more parts of speech into the potential curriculum. So it processed 5,429 files. And it took, so let's see what the stream looks like. Print files, print story stream, not the whole thing, just 0 to, I don't know, 100 or something. Mm, 36, 38, 2, 22, negative. 0, 1. All right, this looks good to me. This is exactly what we want. So file name is that, and then we will have story stream file name equals story stream final, and like I said, I'm going to get rid of that because I want every story to have a possibility to end up in there. And I think that that is good. Let's do it. Let's write it. So with open file, what did I call it? Story stream file name. Write UTF-8 as f json.stump indent equals 4. So I think that this will be our story stream that we will use for training our genetic algorithm. Let's go ahead and write this, and then we can look at it before we proceed. All right, str object cannot be interpreted as an integer. Str object cannot be interpreted as an integer. Dump missing one required parameter. Usually it's easier to get something written to a file than this. Well, that's the risk you take when you write it by hand, right? Oh my God. JSON.dump. Oh, the file comes after. Don't think that's how I would have designed that, but whatever. Oh my God, did it finally do it? I was beginning to lose all hope. So, story stream final. All right. Here's our scoring story stream. Scoring story stream. Oh my God. All right. Okay, story stream, read UTF-8. And then JSON.load, not load string, load file data equals, and then it's just going to be, well, no. Story stream data, just like that. And then print story stream data 0 to 100 and length of story stream data. Run that. Oh, I didn't mean to kill the timer. En equals time.time. Print elapsed time, en minus st, and engage. It takes longer to load than I want, but whatever. Okay. It's probably all this conversion nonsense. Maybe we could pickle it. Okay, we're gonna have my data equals well, let's start with my data postanum and story stream data like this. I don't like it taking like multiple seconds to load. It's just annoying to me. So postanum. Okay. Show me code to pickle this dictionary of objects. To pickle your dictionary of objects, you'll need... That makes sense. Import pickle. I don't need that. Okay. My pickle file, I guess. I don't know. My pickle file dot pk. Data has been written to grab this. Okay, that took 3.62 seconds. And then how do we load it again? Pickle.load. I think we can probably figure this one out. Data's been pickled to here. So my pickle file, read binary, load file, my data equals that. Hopefully we don't need any of this other stuff yet. Since I want to delete that so bad, apparently. File not found. Well, that's unfortunate. Oh, my data.pkl, is it in here? My data.pkl, yes it is. I hate you. I hate you so much. open in Explorer. Somehow still managed to put it in the wrong place. Okay. So mypicklefile.pk. PKL? Okay, it can be PKL, that's fine. And let's see how quickly this loads. That is much better. I'm satisfied. You satisfied? I'm satisfied. All right, so we want, these are our variables. Equals my data then everybody's happy. Okay, and then we no longer need these. Okay, sheesh. Doesn't seem like it should have been that hard to get this data in here. Okay. So I deleted my starting thing, didn't I? That's fine. That's fine. So stub equals list of range of 8 plus we can just do 2 of these. We're going to do part of speech to number, something, part of speech to number. I believe it was noun, dog, dog. And this was noun, cat, cat. Let's see what the stub is. Story stream data equals my data, nothing. So run 0, 1, 2, 3, 4, 5, 6, 7, 82, 98. Elapsed time 0.42. I'm happy. All right. Now I'm wondering if we ran this through our existing scoring algorithm, what it would kick back. I don't see any reason that we can't. So let's see. Scoring kernel, scoring GPU. Let's just get this working right now. So we're going to need these imports right here. Evolve. Probably won't need that. And where is it called? So scoring GPU is called down here. dstream. Evolve curriculum. My story stream. It's not called that anymore, though. It's called story stream data. And then all the sets I. It's not going to be all the sets. It's going to be, well, let's see here. Let's get rid of this. And let's say if 0 is less than or equal to stream j is less than length of one set and one set stream j. So I need to convert this set format. Yeah. So we'll say first empty set equals 1 times, I don't know, 8, I guess, plus 0 times 92. And then we're going to say first empty set. It's not empty. Base set of this is 1, and then base set of cat is also 1. So just the first 100 parts of speech. This should execute extremely quickly, I think. So let's see here. Print base set score, and we'll pass it scoring GPU like this. And it's not going to be this. It's going to be the base set and my story stream. Maybe I just should call it my story stream. No, it's fine. And then block size. Block size is a constant. Once this is loaded, we should say assert length of story stream data mod block size equals 0. Story stream data must be divisible by block size. Must, yeah, okay. Run. All right, so the base set score is this. Do we want to scoring CPU? Just for sanity's sake, let's just make sure that we didn't screw anything up. Let's say do not use scoring CPU, and we can just make sure that it's the same. Do not use one set and stream. Base set and stream. And run. List index out of range. Not cool. Not cool, man. Array size. It's not going to be array size. It's going to be length of stream. And this needs to be if stream of j is greater than or equal to 0, and it is lesser than the length of one set. All right. So we can verify that the, oh my God. I forgot how slow it was calculating on the CPU. Now, this is why we're using CUDA. Holy crap. This is only going to 1,000,000. This should not be taking this long. Is something wrong? Yeah, it's only going to 1,000,000. What is going on? dstream. No, not dstream. What have I done? I don't even know what it was trying to... Was it trying to read from the GPU? I'm like, I mean, I know it's slower, but it shouldn't be that slow. All right, so yeah, these are the same. This is redundant. Redundant. Do not use. All right. Okay, it's the same. I'm satisfied. Let's see if we can do it. So base set score is this. Base set score is this, and perfect score, which obviously we'll never reach, is okay, it's the length of story stream data divided by integer divide by 50 times 50 to the 4th power. So yeah, perfect. Obviously, a perfect score is quite a bit bigger. Is that one space? Let's get the let's make it line up. Yeah, so we've got quite a bit of room to grow. Well, we're not going to reach a perfect score. That's not even on the table. So what do? We want to figure out the next 100 words we're going to do, the next 1,000. How high do we want to go? I think. I mean, obviously, I'm anxious just to just tune it up. How high does it go? Let's take a look at our data here. Print stub. Okay, so print. What kind of words are we looking at if we look at like the 2,500th? So we'll go number to position 2,500. I have a feeling we're probably going to want to go to like 10,000 or something. Refrigerator. And if we go to 10,000, leap. How high do these go? 20,000? I don't think it goes that high. Crabby. Yeah, you see, I don't think we want to go that high. So let's go 10,000, because yeah, we want an optimal solution, but we also want to focus on the most common words. So I don't really know how to handle that. All right, so we need to make a set of sets, and I'm gonna try to not actually do the simulation. I'm gonna try to not prematurely optimize. I'm like, oh yeah, I can do this. Oh, I can do this. It'll save. You know what? Maybe it will save a little time, but right now, my focus just needs to be on getting it to execute the set of sets. So, okay, list of sets equals, boom. Num sets equals, I don't know, I kept throwing around the number 300. Let's just say 300. Okay, so for I in num sets in range num sets, current set equals, we're going to have the base set is going to be the beginning of each of these. Base set. Do we just want to go completely random? Like, I mean, I don't see why not. Base set score. Okay, and we're going to have set size. What did we say? Did we say 1,000 or I don't remember what we said. It doesn't matter. 2,500. Making this bigger isn't actually going to slow it down that much. It's mostly going through the 1 million over and over again. But there is the act of copying the set, so it's not negligible. I don't mean to imply that. Set size is 2,500. So that means we can use words up to 2,500. All right. So we're going to say current set equals list of base set. So that should make a shallow copy. It's not very explicit that that's what we're doing. So copy. Available equals I for I in range set size if I not in base set equals set of base set, not in base set. Yeah, that looks pretty good. In range num sets. Why is that not working? For j in range num sets, now we're going to say while length of CS is length, or wait, no. CNT equals 0, right? And then while CNT does not equal 0. It equals the length of base set. While CNT is less than items per set. Now this is something I didn't even think about. So items per set, capital. While count is less than items per set, we are going to say available. If CS, while length of CS is less than is less than set size, CS.append 0. While CNT is lesser than items per set, assert length of CS is lesser than or equal to set size. Okay, CNT plus equals 1, and then we're going to say CS of available dot pop secrets dot rand below length of available equals 1. Okay, now here we're going to say assert that the sum of CS is equal to items per set, and the length of CS is equal to set size. Okay. Let's see if I've screwed that up. Now, list of sets dot append CS. Is that what we want to do? No. CS comma available, because we want to have the opportunity to add other parts of speech in during the evolution process. And available is going to be the parts of speech that are available to us. So let's see here. Assertion error, length CS equals set size. Why does it not equal set size? sum of CS and length of CS. That should be the right size. I don't know what's going on. 10, 2500. Items per set. Well, CNT is less than items percent. CS.available. Is this obvious to you? Because this isn't obvious to me. This is actually kind of confusing me. So 100. So we went through and we set these. Two, three, four, five. These should not be in here. Base set set equals set of base set. Something is wrong. Base set set. Oh, for hell's sake. No. You're right. Okay, base set set equals I for I in range length base set if base set of I. How much wood would woodchuck chuck? Okay, so, and then it should skip 98, right? It does. Okay, so we don't need that. But for some reason, CS doesn't seem to be going up. And I don't know why that is. Print sum of CS. Print sum of CS. So we should watch it go up here. While CNT is less than, print CNT. Just solved this. Okay, you can stop now. Simple, silly little typos. So, oh, it's still printing way too much stuff. Where are these prints? Print. We don't need available. We don't need count. Okay, so we should have 300 different sets. So let's see. List of sets 0 and list of sets 1. Okay. They're somewhat sparse. They seem to be mirroring each other. No. No, they don't. This is probably the dog or the cat one, so yeah, that's fine. They don't otherwise mirror each other. All right. Okay, I'm feeling pretty good about this. So what we're gonna do is now, wait, we also need a used. Used equals base set copy. All right. I would like to double check this. I'm really afraid I'm gonna make a mistake or something. So, all right. So n and then used dot add n. Okay, and then we want to make sure, and length of used equals items per set, and then we also want to put this in here because we have to know what we can take out, right? Extra we can't touch the base set. That's verboten. That's against the rules. So we can only pull out extras. We don't want used. We want extra dot append n, and length of extra plus length of base set equals items per set. Let's see if that is still valid or if I screwed something up. It does not appear that I screwed something up. So from that, we should be able to calculate the score of all of our initial sets. So actually do the simulation. Sets are what? Are configured? Okay, oh, and then we want last score none, because we haven't run it yet. You know what? I just realized if we want to be able to edit this, it needs to be an array. So for ARR in, that was right. That's exactly what I wanted. So we're going to have my set available, used, and last score equals ARR. Will that work? Do I have to do it like this? Well, let's see if it works like this, and if it doesn't, then I will I'll change it. It worked. Okay. God, I love Python. All right, so now if, ooh, we probably want the last score to go first, don't we? And if there's a tie, secrets.rand below 2 to the 64th, there is never a tie. So ignore the random number. Last score. There's never a tie. So now, if used, let's make this a method. Def calc scores. And it's going to look just like, what did I do? I was holding shift. So if last score is none, then last score equals, where do we do it? It's not going to be the base set. It's going to be my set. Everything else is identical. Then last score equals that. But it's not last score. It's going to be ARR of 0 equals last score. And honestly, that's it. Calc scores. Just calc scores. And then print list of sets. And then that should give a, whoa. List of sets dot sort. And then that should give us, we want the biggest number first. So what if we made it negative? Does that sound good? I think that sounds good. That way, the biggest would be first. Now it's angry about something. So typing of intrinsic call. Oh, we show you actually tried to do something useful. Now it's time to mess with you. Last score equals negative, scoring GPU, my set, length, block size, dstream. Okay, what is it angry about? No implementation of function, built-in function, get item found for signature, int 64, int 32. There are 22 candidates. Okay, so is this somehow getting converted to int 64? I don't know how it would be, but so where does it actually fail? Okay. Okay, let's make sure that my set is actually the list that we are expecting. So print my set. Because the most obvious thing is that I just straight up have the wrong data that I'm passing. Int. My set is an int? Oh, for hell's sake. Well, that would break it. That makes sense. So, all right. Wait, didn't I print? Apparently not. Print ARR. No, just print ARR. All right, so we do have some variability here. Did we actually gain a digit at some point? No, I don't think so. Well, maybe after it evolves for a while. So let's see what it actually is. We'll say ARR available and used. I want to find out what these. They should be arrays actually. Okay. Set. Used. Used is not getting incremented or something. It's because it's supposed to be extra. Extra, extra, read all about it. Okay. So, yeah. Now, these are extra. So this isn't actually going to touch the base numbers, and these should not overlap at all. There should be nothing in available that's in used or that in used that's in available. And so to evolve, we are just going to choose one available and one used, and we're going to swap them out, and then we're going to update it. So yeah, let's do that. Okay, so calc scores, I do think we want to sort. So for I in range, I don't know, let's just do 10 evolutions at first. Print it, oh my god, I didn't know that I wanted to say that. Iteration I, iteration I best score is list of sets 0, 0, and let's just make it negative. So the best score is that. And of course it's not going to change because we haven't evolved anything yet. Okay, so calculate scores. Now we're going to evolve. Def evolve. And I think everything will evolve just once. So yeah. Okay, for I in range length list of sets. Yeah, and here we need to say list of sets equals list of sets. Well, no. While length of list of sets is greater than num sets. Okay, I'm worried about this going a little slow. Is there a more efficient way to truncate my list? I assume that there probably is. All right. Assert length of list of sets equals num sets. Iteration I best score is that, and now we're going to evolve. So length of list of sets. I'm pretty sure that that's going to be constant. It will be. It will be. I don't know why I was worried. I just hate accessing that in the loop. Maybe it's my old C++ days coming back to me, but all right. So we are going to take where's our iteration? All right, I no longer have one. That's annoying. So last score. Thank you. Where did you get that? I'm just blind. Last score, my set available used list of sets of I. Then we're going to say last score is none because we're going to change something. So now item to remove equals available dot pop secrets ran below length available. Thank you. And then item to add item to add is available to pop secrets ran below length available. Okay, now we're going to assert 0 equals oh god, can't do this. Everything needs to be a copy. Okay, my set equals my set dot copy. Available equals available dot copy, and extra equals extra dot copy. Because I mean, otherwise we're going to be splitting it up, which is bad. So assert 0 equals my set of item to add, and 1 equals my set of item to remove. Now we're just going to flip it. So item to add now becomes 1, and item to remove now becomes 0, and assert that the sum of my set continues to be items per set. Is that correct? Yes, it is. All right. Now we are beginning to get somewhere. We're going to say list of sets dot append. What is this? Oh, it needs a new one. So just none secrets rand below that. My set available extra, right? My set available extra, yes. And we can remove these asserts later. So let's run this and see if it actually does improve. Tuple object does not support item assignment. Oh, but it does. Array of 0. But it's not a tuple. I specifically made it not a tuple. Oh, got it. Wow. That is changing less quickly than I expected. But let's see if we go, well, you know what it probably is? It's probably because I went too high with the numbers. But you know what? That's fine. Okay. Now, if length of available is 0, then continue. Because there's just nothing that we can do at that point. Okay, the numbers are increasing. I should have had more faith. We are evolving 300 of them at a time, so I think that that's pretty good. These numbers are getting significantly better. I might want to increase the number of items. I might want to increase the number of iterations, and I certainly want to save my results so that I'm not starting from scratch every time. Oh, God, I just realized something. No. What I was about to say was wrong. I thought that I had forgotten to not touch the initial things, but that's taken care of with the available and extra, so I think I have been sitting here for too long. Why does it seem like it's slowing down? No, it's not. It's just the screen is filling up, I guess. Okay, we haven't seen a lot of improvement for a while here. Now, what I would probably do, okay, it's obviously working, so we should be able to interrupt this here. So yeah, after 407 iterations, Okay, so iteration 0 was whatever. Iteration, I don't remember. $407. So yeah. And let's see, iteration. Much better. Beautiful. Beautiful. Okay, I think that we can probably save the evolution and then resume. So now obviously if I'm doing 1,000 it's going to run slower. But that's okay. So you know what I want to do? I want to actually look at what it's doing. So I'm going to set the number of sets really low, and then the number of iterations well, it's just going to be the set size, right? Set size, which I believe is 2,500. And then that way we can see a very small number grow, and then I want to find out what the ending value is. So let's say print set I, and then it's going to be my set okay. My set equals list of sets I 0, 1, 2. Like that. And we're going to say for I in range length my set, if my set I is 1, then we're going to, well, here, let's do this. Parts of speech equals this. Parts of speech dot append num to part of speech I. And then at the end we will print the parts of speech. So before we start, we'll say print set 0. And then at the end, we will print set 0, and we'll see what it does. I'm not sure that we want... Well, yeah, we probably do. If length... If I mod 10 equals 0, then print... Whoa, I am definitely getting tired. I've been doing this for too long. Okay, and I vaguely remember thinking that one of these assertions was, I think it was this one. Very inefficient. So let's see what this does here. Upper bound must be positive. Item to remove, secrets.rand below, extra. If length of extra is 0, that's what I meant to do. So let's try that again. Okay, this is what I was doing before in that simulation, and just look at how much faster it's going. It's like ridiculous. So we started off... Help cake this, say, sat, squirrel, wow, stay, leaves, anything, glad, hammer, kind of random. And then this is wanted, girl, her, can, be, is, feel, felt, toy. This sounds I mean, it sounds like it's significantly making progress. And let's see. So, iteration 2490 is that. Oh wow, look, it's less. I guess that having all of those extra sets really does stand for something. So final iteration best score. Let's see what it does. Go away, run. Final iteration best score. So it increased for a while and then it couldn't increase anymore. Now we just need to pickle it. So I think this one should probably be well, no, it has to be pickle, because it's got, you know, weird set types in here. Okay, final iteration best score. Let's make sure that we can pickle this. List of sets. That's our only state, right? Yes. So, pickle state, right binary, pickle dot save. Is it save? Dot save dot dump. Dump. Pickle dot dump. Object and then file. So list of sets and file. We're gonna go pickle state dot pkl. Pickle state.pkl read, and then it's going to be list of sets equals pickle.load file, and see if it still evolves. Goes slower, but it still evolves. So obviously it's working. Pretty good. Pretty good. Which means that we should be able to save and load and pick up where we left off. List of sets. Put this here, but I'll comment it out. Then I'll put this here. Now, we would have to, quote unquote, recharge the available, but I think that can be done. So let's evolve this and then let's reload it and run it again. We are going to do 1,000 sets, and items per set is still going to be 100, but the number of iterations that we do is going to be reduced to 25 iterations. Run. Oh, damn, that is going much slower. I guess the overhead of the extra sets is pretty big. Oh, it was skipping 10. It wasn't skipping 1. So yeah, now we want to continue where we left off. So I don't care that it's overwriting. That's fine. It's just generating. And let's see. So this should be the final iteration, which should make it the initial iteration when we load again. Run. Iteration. Yes. And then it continues to improve, and we can run this multiple times. But we need to recharge. Def recharge. Not available. Recharge extra. So a lot of it's going to look the same. But extra is going to change. New, you know what? We don't need to do this. List of sets, -1, equals the new extra, right? It's going to be list. Where did we load extra before? Extra. Evolve. Damn it. Where did we define extra? Extra's right here. So extra.append n. Have I confused them again? Item to remove is extra, so it's available. We do want to recharge available. Recharge available. I'm sorry. So -2, then available equals yeah. Okay. Set version equals set of my set. Oh, captain, my captain. Not in set version. So I for I in range set size if I not in set version. And that's it. If we call recharge, then it will do it. And we should be able to run it as many times as we want, whereas before it would have eventually run out of available things. So let's do this. I think we can get rid of the base set. Base set score gone. Where did I make my base set? Base set. Base set is fine, but the actual base set score I don't want to do. All right. So the number is increasing, and I don't know about you. I think this is working. I'm pretty happy. Let's look at what we've got here. Now, obviously, I'm going to run it more. What the hell? Oh, it's MP3s, right? Okay. The and to was she, he, it, they, Lily. It's always Lily. Her day with said his their. I think that this is good. I think I'm going to turn this up, and I'm just going to set it free and let it run for a while and see if it eventually converges. So, yeah, that sounds great. Let's get it started here. Okay, so I don't want to load the pickle thing right now. And this will be, no, set size. In other words, it's going to look at literally every single word for every single set. At the end is when we want to do this. For j in range, I don't know, num iterations equals 5. Okay. We'll say for j in range num iterations, and then before we begin, we will recharge the available, which probably means that I should start it off being empty, but just whatever. Okay, so this time we're not loading it. We're starting from scratch. Print starting simulation with num sets for num iterations. Num iterations and then inner iterations. Oh my God. Ridiculous. Okay, so it should get to the end and write. Okay. Iteration j. Iteration 0 best score. Hey, it's going up. Looks good to me. Once I have established an initial curriculum, I can kick off actually figuring out the story ordering. So I feel like I'm getting close to actually having something to deploy. The idea that you want to focus on a core curriculum rather than just saying, okay, here's every word in the English language, have at it, is something that I actually had trouble admitting, but I do actually think that it is the right course. So, that said, I'm going to kick this off. Items per set. That should be 2,500, right? No. Set size, that's what I wanted. Set size, and then number of outer iterations. And I'll just see where this takes me. So, see ya. Wait. Gotta kick it off. Now I'll see ya.